Name reaction series. Today we are going to see the haloform reaction. In haloform reaction, it is a reaction between the carbonyl containing compounds such as aldehydes or ketone in basic medium, in bromine, chlorine or iodine to get the acid derivative of starting carbonyl compounds. The byproduct form is the haloform. Haloform are nothing but the alkane containing three halo groups such as bromine, chlorine or iodine. It is an example of aliphatic electrophilic substitution reaction. It is one of the oldest reaction in organic chemistry. It was discovered in 1882. The reactant are methyl ketones or methyl aldehydes containing alpha methyl group and some secondary alcohol that can be oxidized to methyl ketone. The reagent used in this reaction are such as bromine, chlorine or iodine with the help of strong base such as NaOH or COH. The product form in this reaction is haloform and the carboxylate salt of potassium or sodium. Let us see the mechanism of haloform reaction. In the first step, the alpha containing ketone. In this example, we have taken the methyl ketone which contains the three alpha proton. One of the proton These three protons are highly acidic in nature due to the electron withdrawing nature of this carbonyl group. So one of the proton is extracted with the help of base, is converted to its enolate. This enolate again attack on the bromine to displace one of the bromine to get the alpha bromo ketone over here. In second step, the remaining there are again two acidic proton. One of the proton is again picked by the base to get the enolate, and this enolate attack on the bromine to get the dibromoketone. So there is also one proton left in this reaction that is highly acidic in nature. This is again abstracted by the base to get the enolate, and this enolate is attack on the another bromine molecule to get the tribromoketone. This tribromoketone at the end is hydrolyzed with the help of base to get the carboxylic acid derivative, and this the acidic proton again here is abstracted by the trihalo uh, anion carbonyl anion to get the haloform and the carboxylate and anion. This anion is in this anion is protonated in acidic medium to get the carboxylic acid derivative, and we get the bromoform as the byproduct in this reaction. Let us see the application of haloform reaction. The first application is iodoform test. Iodoform test is used to detect the presence of ketone functional group or secondary alcohol group in the or given unknown compound. Secondary alcohol are oxidized to initial methyl ketone, and these methyl ketone are further converted to is carboxylic acid derivative using haloform reaction. When there is a yellow precipitation of iodoform, it is confirmed that our compound contains the carbonyl group or ketonic group in its structure. The second application is the synthesis of carboxylic acid. As we have seen in the mechanism, the methyl ketone can be easily converted to carboxylic acid derivative. And the last application, the synthesis of haloform. It has an industrial application where chloroform, bromoform, and iodoform can be synthesized using haloform reaction. And in these three bromoform or haloform, the chloroform is highly used, and it has many industrial application, and it is used as a solvent in the many chemical transformation. We have seen the application of haloform reaction, but there are many limitations of the haloform reaction. The first limitation that is fluoroform cannot be prepared using this reaction due to the instability of hypofluorite ion. The another limitation is that only methyl ketone or aldehyde containing an alpha methyl group can be used in this reaction. This is one of the example. This is acetophenone. This is acetophenone. Acetophenone has three alpha protons. So this can be easily used, and this can be converted to its carboxylic acid derivative using haloform reaction. But when we have diphenyl ketone or benzaldehyde or terbutyl ketone, this three substrate doesn't have any alpha proton, so this cannot be used in the haloform reaction, and we cannot prepare its carboxylic acid derivative. Thank you, guys.